Welcome back to module 13.7. This is our last video for module 13 as well. So let's take a look at how we can solving quadratic equations involving with consecutive integers. So as you can recall back in module 9, we got consecutive integers and we got consecutive even and odd integers. So find two consecutive positive integers. So it does not say even and odd here. So just a regular consecutive integer, the first number is always going to be x. The second one will simply be x plus 1, right? Back-to-back integers. Find two consecutive positive integers. So we will worry about the positive at the end here, such that the square of the second integer, so x plus 1, my second integer, whole thing is being squared, added to plus 3 times the first integer, which we call it x already, is equal to 105, So that's how we will translate for this equation. All right, so once again, my first term here is x plus 1 whole thing squared. So you can either say this is x plus 1 times x plus 1 and forward it out, or we can use the formula, okay, which is a plus b whole thing squared is equal to a squared plus 2ab plus b squared. Okay, either way will give you the same answer. So I like to use a formula because that gave me my answer right away. My a is x, b is 1, so that will be a squared, which is my x squared, plus 2 times my a times my b. 2 times x times 1 is 2x, plus my b, 1 squared. 1 squared is still 1. All right, second term on the left is still positive 3x, equal to 105. All right, so combine like term, x squared is still x squared. 2x plus 3x is positive 5x. Okay, I'm going to go ahead and move my positive 105 to the left side here, so it can be combined with a positive 1. So I'm basically doing step number 3, 4, and 5 all together, okay, on the 8th step of how to solve quadratic equation. So I'm doing a lot of these together, so that saved me some writing. So positive 105 come over, become negative. 1 minus 105 is negative 104, equal to 0. All right, so 104, that will be within 100, within 10 times 10, kind of like. Well, not quite. 104 is between 100 and 200, so I know 200 is 10 times 20, 100 is 10 times 10. So for 104, I'm gonna searching for a number that's either from 10 to 20 or a little bit lesser than 10. Okay, it'll be somewhere right there. I know I'm not gonna use 20 something to go into 104. So for x squared, let's use x and x. For 104, who times who ends with a 4? I'm going to use 9 first because 9 times 6 is 54. So that gives me 11. All right. That's not a whole number, so I cannot use it. So the next one I try is 8. 8 times 3 does end with a 4. Oh, Lord. 104 divided by 8, which is 13. Oh, that's exactly what I needed. 8 and 13, the difference is 5. All right, my outer is 13, my inner is 8. Since the lesson is negative, 1 positive, 1 negative. So to end up with positive 5 in the middle, I need positive 13 on the outer, negative 8 in the inner. All right, so once I've factored it, set each factor equal to 0. So one of my answers is positive 8. The other one is negative 13. All right, now that wording, positive integers. So that means I cannot use the negative 13 for answer. So my first integer got to be 8. My next integer got to be 9. So 8 and 9 will be my two consecutive positive integers. All right. Again, find two consecutive positive integers such that the sum of their squares. So the first and second. First one is x. Second one is x plus 1 once again. But this time it want me to do sum of their squares. Sum of their squares. So we did that in the previous video before. Sum of a square means addition between the first whole thing squared and the second integer whole thing squared. X plus 1, oops, sorry, whole thing squared equal to 85. All right, so now my second term, okay, my second term is x plus 1 whole thing squared. So this x squared is still x squared, okay? This is a positive sign. So tell you what, I'm going to write it above here for a minute. I know the x plus 1 whole thing squared is x squared plus 2x plus 1, right? 2, the perfect square binomial formula that I showed you earlier. Now, this is a positive 1 time. So this positive 1 times these three terms. When I do a distribution, my answer should still be positive x squared, positive 2x, positive 1. The reason why I mention this because sometimes if this is a negative sign, then negative 1 do a distribution after the perfect square binomial will change all the signs. So just be careful. All right, combined like term is going to be 2x squared, x squared plus x squared, 2x squared. Positive 2x is still there. I'm going to go ahead and move my positive 85 over. That becomes negative on the left side. 1 minus 85 is negative 84. All right, so instead of factor out a 2 between these three terms, I'm going to go ahead and divide every term by 2. All right, it does the same thing like I showed you before. Once I factor out a 2, I will still end up dividing both sides by 2 to get rid of that extra factor. So this is going to be x squared plus x minus 42 equal to 0. So 42, I will use 6 and 7. Alright, my difference is only a 1 here in the middle. Since the last sign is negative, my inner and outer got to subtract. 1 positive, 1 negative sign. So to end up with a positive 1, I got to have a positive 7 on the outer, negative 6 in the inner. Alright, set each factor equal to 0, one on my answer. X equal to 6, the other one. X equal to negative 7. Alrighty, so let's see. Does the problem say anything about positive integer? From consecutive positive, it does say it's positive again. So that means I cannot use the negative 7. I got to use the positive 6. So my first integer, positive 6. The next consecutive integer got to be 7. Alright, so that's my two answers. Alright, so in this lecture video, we quickly did 2 examples of using consecutive integers to help us solving quadratic equations. Alright, that will conclude this lecture video. Thank you for watching.